This is Walter Yu here to present the full feature video for my project, which is reducing commute time with machine learning and graph analysis. And so the topic is to analyze a scientific data set using Spark, and this is the output of my Jupyter notebook, which I use to do all my work. The only reason here I'm using a screenshot with the HTML version is because it is easier to scroll through. However, it is the exact same version as my notebook. So the only reason I'm using notebook is to have to toggle between the cells. So with that, here we go. So topic and problem statement have been stated, and then briefly going over here in the notebook, talking about the introduction here, why it's relevant. So basically we're trying to minimize commute time within the US, which has negative impacts. Steps here for data cleaning and preparation are outlined, so basically removing empty values and missing values, negative values, and also outliers. And then a brief overview of the data analysis, which was done with machine learning and graph analysis. So SparkML was used for the machine learning. We'll get into that in a bit. And then the graph analysis was done with Spark GraphX. And so that was to create the graph and analyze the relationships. Tools and modules are all listed here. So primarily Jupyter Notebook, SparkML, GraphX, and then these Python modules to do the other steps, and then also installation and configuration. Basically, they're all modules that are installed within the notebook. So run pip install and import into the notebook. And then basically the parts about the data analysis, which was part of a data challenge that I entered in. So I did the data cleaning and summary statistics for that data challenge, and this builds upon that. So there's a clear separation. This is purely for the machine learning and GraphX, and the data analysis was done during the semester during a data challenge. So this builds on top of that. And so this is the SparkML used to do the data analysis. So with that, we'll get into the code. So here, I just included the licenses, make sure we didn't skip that. And so after that, so that those are basically the licenses for Python, Notebook, all the modules, and also Spark. And then we get into the first module with the code. And so this is data cleaning, so we're going to import the packages, import all the CSV files. So the data set is about 1 million rows composed of 4 tables, so households, people for the survey, trips, and then vehicles. And then we're going to go ahead and do the cleaning as I described. So we're going to take the non-zero values out, same thing with outliers. Go ahead and start to organize the code. So we're going to break it up by columns and then also by census division, because that's geographically important. And then we're going to get into, so I'm having all the import and modules within one, within the first part. And so the Spark and the GraphX is also included here. So these are all the import modules for Spark. And the same thing, except here we're going to import as an RDD. So we're going to create the Spark session and import as RDDs in order to use it for SparkML. And so with that, we're going to get into the data analysis portion of it. So this is just for summary statistics. So we're going to take a look at the household table, which is one of the 4 tables. And we're going to do summary statistics, and then we're going to go ahead and plot it. And so the results here are I'm going to start going over the results along with the code. And so this is a bar chart of the census division by weighted households. We see that there's basically more density and more households along the coast. So there in the Atlantic, on the bottom on the x-axis there, and also in the Pacific areas. So these are regions within the US, and so these show that urban density basically. And with that, we're going to go ahead and continue, and we're going to use the machine learning algorithm to look at a little bit more detail of this household data set. So we're going to look at vehicle count and vehicle usage along with the household. So we're going to go ahead and use the decision tree algorithm out of SparkML. And this is a reference from Lab 10 and Homework 10. And so we're basically going to start our algorithm and our pipeline. So we're going to set up the pipeline, call out the correct columns, and then we're going to go ahead and split our data, go ahead and run it. We're going to print out a R-squared value, RMSE squared, so that's the rate of error, and then also the feature importance. And we're going to go ahead and plot. So that's what you see in the code here. And here's the output. So this is the beginning of it. One thing to note here is that the R-squared, the error is, that the fit is not as good because the other columns tend to drown it out. So we'll see here in the chart is that we see vehicle usage quite, highly associated with vehicle count, which could be used as sort of a proxy for vehicle, basically usage and congestion. So we want to reduce that, but the other factors do not factor in as well. That's why it's dragging the result of the algorithm down a bit. But I think the important thing to see here is that the vehicle usage is closely tied to vehicle count. So that's worthy to note and something to think about as we try to reduce commute times within the US. So this is doing the same thing as above, except with the gradient boosted tree. So this is for comparison. So we're going to take a look at two popular algorithms and see how they perform against each other. And I think also anecdotally within the data science community, the boosted tree and decision tree tend to be the better performing algorithms. And so that's why these were chosen, and using them within SparkML. And so we're doing the same process, again, reference from Lab 10, Homework 10. Calling out the columns, and then go ahead, split our data, train it, and then we're going to get the error rates and then also the feature importance, and we're going to plot it. So similar here, and what you see here is just a little bit better performance, and that vehicle usage is still tied to vehicle count. So again, validating that that's what we're getting in return for this. So next we're going to look at trips per household. So we're going to repeat the same process, and so this is going through the major tables within the data set. We're going to go ahead and break it down, do the initial summary statistics, and then we're going to get into the SparkML portion of it. So this first portion again is the trips table. So this is the annual trips per household. And so this is basically organizing the data, and this is getting in between the households, the divisions, and the trips. And we're going to calculate and put it into a bar chart. And so again, these are results. And so what this is telling you on the chart here is on the lower x-axis there is the census division within regions of the country, and then the annual weighted trips. So how many trips are people driving every year? And here we're putting it with and without subways or mass transit. So we want to compare within not only a census division, but with and without access to the subway system, what would the difference be? And we see that typically the annual weighted trips are a little bit higher with access to a subway, which it could be cause and effect or an association of more access to subway is usually in a higher density area, and that's why people are, well, more people, more cars, and more driving. And so you see that trend there on the right there with the Pacific and some of the Atlantic areas. And so that's another trend to note, is that subway systems in urban areas that may have more driving, but probably just because of more people and more cars. And then we're going to go ahead and use the decision tree algorithm and look for additional relationships. So same thing here, referencing homework in Lab 10, calling out columns, setting up errors, and here's the output. So what we want to find out here is the factors influencing the trips, the distance per trip. So we started to look at the number of trips, and basically how much driving per capita with and without the subway. And what we see here with machine learning is that we start to see additional trips or trip distance, being closely, basically how far someone's going to drive, and then also trip duration is a little bit further behind, but basically that the reasons that people are driving are starting to dictate driving behavior. So we're also seeing that trend. And then here is the gradient boosted tree, similar. So we want to compare for performance. Similar process here, going to call out the columns, find the error rates, and then go ahead and get the output and do a plot. So same thing here, our error and our fit's a little bit lower just because of the other factors, but we're seeing similar with a little bit better performance. So the amount that people have to drive and also trip duration tends to dictate driving behavior, and so that's something that's worth a closer look at. And then next we want to go ahead and take a look at annual miles. So we're starting to look at the different factors around driving, around what could possibly reduce it. So we're going to look at areas within the country, with and without subways, the vehicle count, the vehicle usage, and now we're looking at how many total miles they're driving. So brief overview there of the data analysis, and then using machine learning to build on top of that. So again, a very clear separation between what was done in the data challenge and here in the project. And so this is a similar process where we're going to clean and break up the data. And so we're going to break it up by census division, and we're going to generate a plot. So these are the results. So Y-axis there is the total annual miles per division. Lower x-axis are the same, similar breakdown as before, so by census division with and without subway. And so here we see, especially there in the Pacific and Atlantic, we see a drop actually in the total number of miles driven by census division with and without the subway. So this could indicate that, well, there's more people, more cars, and more driving. But when you look at the actual total miles, that it does drop with a subway system. So that indicates a larger trend of urban systems with or urban cities with the subway could lower the total usage of cars, even though there's more people and shorter trips involved. So here we're going to use the decision tree algorithm using SparkML. Similar process as before, homework 10, lab 10. And we're going to do some output here, and we're going to look at the factors that influence these miles that are driven annually, total miles. And so, and sorry, on the left-hand side there, in all these charts is the feature importance. So from 0 to 1, how good is the fit? And so we see there is that basically household annual income and the vehicle count tends to influence this. So this could mean that more wealthy people tend to drive as they need to, and they have that luxury, versus the other factors we have in there were driver count, and the other factors were not as influential, including urban density, which seems to indicate that they're separate. So maybe it could be driver and usage are, they go together, and it could be more socioeconomic in nature. And then we're going to repeat the same thing with the decision tree algorithm here, and that should be gradient boosted tree. But we see a similar result with a little bit better accuracy. And then the last portion of this analysis, we look at the commute time per household. So this was only done with data analysis, no machine learning here, but very quickly we're going to basically organize the data by census division. And just to round things out, we're going to look at the commute time. And so again, we compare it with the subway, and we see that the commute time is a little bit higher with access to a subway. And again, this seems to indicate that more urban areas, more congestion, and therefore longer commute times. So not completely indicative that it's encouraging more driving, just that there's more people. And then the graph portion of it, so as I pointed out previously, the GraphX, it did work, and I included output to where it worked, but doing a final check, the jar path broke, jar file path. So I'm just going to go over it. You will see the error message, but I left a note just documenting because I do want to move and complete this project with so many deliverables. So basically this is to examine the relationship. So we're going to set up a graph based on basically taking a look at the in and out relationships. So here we're going to go ahead and import the PySpark modules, import the CSV into RDDs, and then we're going to set up the graph. There's my big note. Basically we're going to look at the households and trips data, and we're going to set it up as vertices and edges. More notes here, and the output would have been the in and out degrees, and taking a look, same thing here at the feature importance, and then also go ahead and generating the plot, and that's in my PowerPoint, the correct output. And that was it for the graph analysis. And what that basically told us was that, let's go back here to my slides here, is that it would have been, this is the output here. So basically this gave us the total count, and this basically told us that there are basically more total trip counts with higher urban densities. So again, it's detailed out a little bit more here in the slides, but that's what that told us. And then going back to notebook here, after the error message here, so some lessons learned. We have the pros and cons of each technology. So SparkML was a good choice for analyzing large data sets. Spark scikit-learn, though, could have been used for the same cases, so that's a con. GraphX is good generally for more RDDs and pipeline work, but again, it doesn't seem to be very mature because there were no modifications to the code, yet the jar file path broke after working twice. And there are other choices, honestly, Neo4j or other tools. Though GraphX could be used for production because it works nicely with pipelines. And then some takeaways there from the data analysis. So again, as I said, mass transit doesn't seem to be tied to driving. So the two efforts seem to be separate. Urban areas seem to have urban density seem to have a high impact, and then also more wealthy income households, and then also the trip destination. Those are very big factors, and these are more the actual results for the table. So this is more what did we find from analyzing the data. So basically that those are the findings for each table. What are some trends? So basically looking at those demographic groups, like what more wealthy households, and then also transportation planning could be looked at, and then some next steps, which is basically building out this analysis. And so more could be done because this was an initial effort, and that's about it. So thank you for watching my video and going through the demo. Thank you.